Okay, guys, welcome to week 2 of physics. This week we're going to talk about speed, velocity, force, and work. So it's a lot of terms. I put a little bit of the start of this lesson into last week, just to decrease the workload this week because it's probably the biggest week for physics. So you might have already touched on some of these topics, which is perfect. Hopefully everything's clear. Hopefully you remember how to do slope, line of best fit, and those kind of things from those lessons because it's very important. All right. So we're just going to jump right into it. Moving on. So this I'm going to replace with this new video I'm creating right now because the sound was all muffled on that one and I didn't realize. So I'm going to redo it right now. Right here. So we're going to jump right into this, which is page 17 of your notes. And I'd like you to notice that this little box right here. Okay, so this box right here, that's just the answers to the questions on page 16 and actually page 17 because the last questions right top. Those are your answers, so feel free to go over them, make sure they're right. So now we're going to talk about the new content. So the big thing, new content is know the difference between speed and velocity. So the difference between speed and velocity is whether you're calculating a vector quantity or a scalar quantity. In other words, it has direction or it doesn't have direction or magnitude. Speed is distance over time, and velocity is displacement over time. So the difference between the two, I guess, if you travel to Medicine Hat and it takes you an hour, and let's say Medicine Hat's 110 kilometers away, you traveled at 110 kilometers per hour. Okay. Whereas displacement is the exact, let's say the road to Medicine Hat is like this. It is simply the straight line between finish and end. So if this is your final point and this is your final point, so you can tell that this windy line is going to be a lot longer than the straight line. So displacement is your velocity is almost always going to be less than your speed. That being said, unless you're running an exact perfectly straight line, then they will be equal, but they'll never be larger. So that's something to keep in mind here. So the formula is distance over time for speed and displacement over time with speed. Oh, this is not working very good for me. Okay. And you'll notice that the difference too is there's a delta symbol here in this symbol. Okay. So delta means change in. So this triangle is delta. It means change in. So it's change in displacement over time. And it should be change in time as well. So yeah, so if you're talking about distance, it's going to be speed. If you're talking about velocity, it's going to be displacement. And we're going to use those two terms sometimes interchangeably. So keep that in mind for physics. But it's just a very important thing to know the difference in. Okay, so remember that, please. So yeah, and a little way to remember which one's a scalar and which one's a vector is just the first letter. So speed is with an S, that is a scalar. Velocity is with a V, that is a vector. Okay, that's how I remember it. So let's jump into an example here, if it will allow me to. Oh, I see what's going on. So average velocity. So we're going to calculate the average velocity, not the average speed here. Okay, so average velocity. So we're talking displacement. All right. So what we need to do is distance over time, or sorry, displacement over time, uh, and it is change in displacement. So a big thing is here, we're not starting at 0 for distance. We're not starting at 0 for time. So it's going to be a subtraction question. So your time is actually going to be final time, subtract initial time. So 4.55 subtract 1.05. Okay. Um, that's going to be your overall time. That's going to be your change in time and your change in distance. So it ends at 56.23, but you'll notice that it's measuring from the front of the car and the car is 3.25 meters long. So we need to subtract a 3.25 meters. Okay. And when you're doing this, okay, it's important to do that to make sure that you have the proper change. So the actual formula for this, oh, my camera's in the way. Let's see if I can move it. That's not what I wanted to do. I'll just exit it maybe. Yeah. So this is your formula right here. Okay. So change in distance over change in time, the arrow above the D means it's the vector quantity. So these are the numbers that I wrote right here. And your final answer in vector is 15.1 meters per second, right? So how they found this answer, they just did your change in. So they did the top of the equation, then the bottom of the equation, divided the two, and they got this as your answer. Okay. So that's a harder version of these questions. So feel free to give these type of questions a try. You should be up to page 19 in your notes here now. So go give those a try. And like I said, if you're mastering something, okay, feel free to not go through every single question. It's important to still read through them in case you see a question that throws you for a loop or has a little ripple that you hadn't seen before. But just make sure that you're, excuse me, that you are in fact doing that. Okay, doing what you need to do to be a master at this. Okay, so now we're going to talk about graphing. We'll always talk about graphing. It's an important thing in physics to understand the data and to be able to present the data to people easily. So there's going to be two types of graphs that we are going to. So there's going to be two graphs when it comes to uniform motion. Uniform motion means continuous motion. Okay, so they're either going to look like this here, okay, or this here. Okay, uniform motion is indicated by a linear position time or distance graph. So position time or distance time. Okay, so it's going to be here. Okay, so it's going to be increasing over time. Your position is increasing over time. So you're getting further and further away from your origin. Okay, the slope of this line on a distance time graph or position time graph, depending on whether it's a vector or scalar, is going to be your average speed. So once you calculate slope, okay, as you guys are all masters of from grade 9 math and from our first physics unit, when you calculate your slope, that's going to be average speed or velocity, again, depending on which is what's over here, whether it's distance or position. Okay, down here, this is going to be a uniform motion. That means your velocity doesn't change. So uniform motion means that you are going the same speed all of the time. Okay, so in these types of graphs, if you have a velocity time graphs, this line is going to be perfectly parallel with your x-axis here. So it's going to be straight along, okay? Because your speed isn't changing. Velocity is on this side, or speed, and it's going to stay the same. You're going to be going 25 kilometers an hour the whole time. And the reason why these are important because when you get into calculating the area of these graphs. So if you calculate the area of this graph, so let's say you want to know how far you've traveled at this point. When you calculate the area underneath your line that you've created, that's how you calculate it. So let's say, for example, this was the 3-hour mark. Okay, and you calculate your area under, and let's say your velocity is 100 kilometers an hour. So your 100 base times height times your 3 hours, it would say that you went 300 kilometers. All right, so the same under here. Okay, distance that you've traveled. Yeah, so at this point, you should be good to do up to page 26 in your notes. I'd like to remind you that that seems like a lot of pages from 19 all the way to 26, but there were some printer errors in there, and there's some pages that are very close to being completely blank, so don't panic. Also, graphs take up a tremendous amount of space in those note packets, so there's not as much as you actually think there is there. So go through it, like I said, if you do one or two and you're like, this is too easy, I don't need to do them all, just skim through, read the questions, make sure there's nothing that you don't know how to do, and then feel free to move on, okay? Because we have limited time here. That being said, if what I'm saying, which is perfectly understandable, doesn't make sense to you, or you want to read it rather than listen to my voice, in your textbook on these pages, there's some more practices. And there'll be answers at the back of the book. There should be answers at the back of your textbook. And also, if you look at the little section leading up to these questions, so the pages previous, it usually breaks it down a little better than, well, not better, but a little bit differently with step-by-step guide to how to do it, just like they do in your math textbooks. So there's extra practice here if you think you need it, or if you need a different version of the notes or of the questions than what's in your note packets. use this as well. Okay, so yeah, that's all for this time. Please reach out to me if something isn't clear. I'd be happy to help you with this. Okay, so the best, and we'll see you in the next video.